Good morning, good afternoon, good evening, depending on what time you are watching this video presentation class and depending on which country you are watching from. Today we are going to be having a class on binary number system for basic 6. Binary number system. And we're going to be looking at how to convert binary numbers, then addition of binary numbers. Also, we're going to look at subtraction of binary numbers. Then we would also look at multiplication and division of binary numbers. So ride with me as I take you on this exciting journey. Introduction will be our first discussion in this class. Then we'll talk about the conversion to base 2, conversion to base 10, that is conversion of numbers between base 2 and base 10. We're also going to look at addition and subtraction of binary numbers. We will look at multiplication and division of binary numbers. In this first class, we would be looking at the first 3 outlined topics here: introduction, then conversion to base 2, then conversion to base 10. And in our subsequent lesson, we're going to look at addition and subtraction of binary numbers. Then we're going to also look at the division and multiplication of binary numbers. Our learning objectives are as follows. At the end of this lesson, pupils should be able to do the following. And sorry for this typographical error. Okay. So at the end of this lesson, people should be able to attain the following objectives. 1. Conversion of base 10 numbers to base 2. Number 2. Conversion of base 2 numbers to base 10. Students or pupils should be able to perform basic addition and subtraction of binary numbers. 4. They should be able to also perform basic multiplication of binary numbers and division as well, which is not very common at this stage, but we're going to introduce it as well. Then solve quantitative reasoning questions. So introduction. This is going to be the first lesson, and we're going to be introducing the binary number system. Binary numbers are composed of only 2 numbers, which is to do with just 2 kinds of digits, the 0 and the 1. While decimal numbers, on the other hand, are composed of digits from 0 to 9 in various combinations. The first class activity we're going to be doing right now is conversion of base 10 to base 2. Conversion of base 10 to base 2. Binary is a number system that represents a base 2 number system. This means it has only 2 numbers which range from 0 to, or 2 types of numbers, which is between 0 and 1 in various combinations. Now let's look at the relationship between decimal and binary numbers. But before we do that, I want to let you understand that binary numbers are just 2 digits that it deals with in various combinations, zeros and 1, and that is the numbers that the computer actually understands. But we're not looking at computer science today, we're just looking at mathematics. Now, zeros and 1 can be combined in different forms to form a binary number. It could be 1 0, it could be 1 0 0 0 0 1, it could be 1 1 0 1 1 0 in various combinations. But let's look at the relationship between a decimal number and a binary number. Now to my left hand side right here, we will see the decimal numbers lined up from 0 to 11. Okay, them 0 1 2 3 4 5 6 7 8 9. Now take note of something from the decimal numbers. It started from 0 1 2 3 4 5 6 7 8 9, and look at the next number, 10. If you take a look at this next number, you will realize that this next number is a combination of the one of two of the first 9 numbers that you are seeing here. Now you see the decimal number already consists of about of these digits between zeros and 9. So by the time it gets to 9, it has to reset and start over again. Let's take for instance, you are starting from 1 2 3 4 5 6 7 8 9, which is the last digit represented in the decimal number. Now the next one, that 9, if you count them, is going to be 1. Count from 0 1 2 3 4 5 6 7 8 9 10 digits. You see that? 10 digits. So it has to reset and start again. Now, so the first 10 digits will represent one set of number, then the next digit again is what? 0. Now you have to come to the next one, which is going to be, bring this one down, you add another 1 to it, you get what? This. Now for instance, when you stop at 9, which is the 10th digit, and you need to continue to the next number, you bring 1 down, which is first set. That means you have gotten your first set of numbers. Then you start with what? 0 again. You put the 0 to be 1 0, which is 10. Then you put the next number is going to be 1 1, which is 11. The next one is going to be 1 2, which is 12. The next one 1 3, which is 13. The next will be 1 4, which is 14. The next 1 5, which is 15. The next 1 6, which is 16. The next 1 7, which is 17. The next 1 8, which is 18. Then next 1 9, which is 19. Take note again, we've completed another set. We need to move to the next set. So we have 1 9, which is 19. Now we've gotten 2 sets now. Then it becomes what? 2. Then we'll start again with 0. 2 0, which is 20. 2 1, which is 21, like that, and so on and so forth. On the other hand, the binary number, the equivalent of these numbers, or these decimal numbers we have on the left here, the equivalents are as follows. Now look at this. 0 0 is 0. Okay, that is the starting point. 0 is 0 to base 2. This is also 0 to be on my left, is on the decimal side is 0 to base 10. Okay, this is 0 to base 2. Now look at 1. It's just 1. So 1 to base 10 here is 1 to base 2 on the binary side. Now let's look at this number 2. Now look at it gets interesting from this point. Now look at this number 2. Number 2 coming here becomes 1 and 0. Why? Now take a look at this number. Binary numbers only consist of zeros and ones. Okay, it consists of only zeros and 1. Now from what we explained on the left hand side, which is this section of decimal, let's apply it to the right hand side. Now look at this number 2. In the binary section, we only have zeros and 1. We don't have 2. Okay, but when we go to something like the next type of number, we might have something like that. Now, but let's look at these binary numbers. By the time you look at the number 2, you will see that we cannot write 2 on the binary side. Why? Because binary numbers only have zeros and 2s and 1s. Now let's look here. By the time you get 2, you see that, okay, let's convert 2 to a binary number. Now we take zeros, we've counted 0, we've counted 1. By the time we count 1, binary numbers only have 2 digits, or 2 types of between zeros and 1. Now by the time we count 0, we count 1. The next number, because we have completed 2 digits, we need to reset and start again. So that is, we've gotten one set, which is 1. Then we start counting again, 0. Okay, so 1 0, just like we did when we go to 9. you know, we say we have completed a set of 10 from 0 to 9, a set of 10. Then we start again and say, okay, now one set is formed. Then let's start again. 1 0 1 1 1 2. In the same vein, when you have counted, when you say 0 1, a set is complete. So you right, come down, you now have 1 and start with the 0 again, and come with the 0 again. 1 0. Okay, and then 1 1. A set is another set is complete. Okay, so you now have 1, okay, 0, okay, yeah, you have gotten a set complete. So you now have that as it's supposed to be, as you can see right here, that this number is 0 again, then 0. Okay, so that is how it goes down and on. But don't worry, I'm going to be showing you how to convert it from this binary numbers to from binary to decimal. We're going to be doing that much more later, but this is just the technique. It is from 0. When you count 0, you count 1, it's complete a set. Okay, you write one set down, then the next number becomes 0, then the next one is going to be 1 1. Then by the time you put the next number, it's complete again. It's this is currently complete, so we'll move on just like that. So we're going to proceed. Let's start by converting from decimal number to binary number using the division method. Let's take, for instance, we want to convert this number 122 to which is in base 10 to its binary equivalent. What do? Now we write the 122 on my left hand side, then we divide by 2. By the time we divide by 2, 122 divided by 2 is going to give us 61. And by the time you check it, there is no remainder. You have to write your remainder here, remainder 0. Now you bring your 61 down to this point, divide it by 2 again. You're going to have 30, which is 60, remainder 1. You write the remainder here. You bring your 30 down to this point. Okay, now you divide 30 by 2, you're going to have 15, remainder 0. Okay, you bring your 15 down, you divide it by 2, you have 2, that's 2 divided by 15, you're going to have 40. To go into 14 twice, 7 times, remainder 1. So you write the remainder 1 here. You bring your 7 down, divide it by 2 again, you have 3, remainder 1. You bring down your 3 here, divide it by 2, you're going to have just 3 divided by 2 is going to be 1 time, remainder 1. You bring the 1 here, then bring the 1 that is remaining here down here, divided by 2. You cannot divide 1 by 2 without perfectly, so it's going to be saying it can go 0 times, remainder 1. Now look at the numbers, the binary equivalent of these numbers. How do you pull them out? You pull those numbers out from the base, from the bottom to the top. That's why you're seeing this arrow coming from bottom to facing from bottom to top. Now we're going to say 1 1 1 1 0 1. This is the binary equivalent of 122. 122 in base 10 is equivalent to 1 1 1 1 0 1 0 to base 2. That is the way you convert from decimal to binary using the division method. Now let's proceed. Then how do you do the other way? How do you now convert from what we've done earlier is to convert from decimal to binary. Now how do you convert from binary back to decimal? How do we do it? There are several ways, but in this class we're going to be looking at basically 2 ways. This one and one other one I'm going to introduce as we proceed. So let's see it. Now let's take, for instance, we want to convert this binary number 1111111 to the decimal equivalent. What do? Okay, now with these numbers you write them down like you have seen written here. You write them down, come here and write, because it's a binary number you are converting, that you are looking at base 2 number. So we're going to write 2 on each of these boxes like we've seen. Now we count from from right to left. You're going to start 0. This is the 0 position. 1 2 3 4 5 6 7. Can you see that? Okay, 0 1 2 3 4 5 6 7. Now we come here, we have already written 2. Because this is 0 position, we put it raised to power 0, 2 raised to power 0. This is the 1 position, we put 2 raised to power 1. This is the 2 position, 2 raised to power 2. This is the 3 position, 2 raised to power 3. 4 position, 2 raised to power 4. 5 position, 2 raised to power 5. 6 position, 2 raised to power 6. Then this is the 7th position, 2 raised to power 7. Okay, now we'll look at this first number. Is this 1, right? So we're going to say 1 times 2 raised to power 0. Anything raised to power 0 is 1. So it's going to be 1 times 2 raised to power 0, which is 1 times 0. Anything raised to power 0 is 1. So 1 times 1 will give us what? 1. Now look at this as well. This is 2 raised to power 2 times 1. Okay, 2 raised to power 2 is 4. 2 raised to power 2 is okay, sorry, we are here. 2 raised to power 1. 2 raised to power 1 is 2 times 1. This is 2. Then 2 raised to power 2 is 4 times 1, 4. Now look at the explanation here. Okay, now look at it here. Let's come to this other one. By the time you add all these numbers together, okay, you're going to have 256. So 256 is the binary, is the decimal equivalent of this number. Now let's look at the second example. You have 1 0 0 1 0 1 0 1. Okay, now by the time you put the 2 raised to power 0, which is 0 position, then 1 position, second position, third, fourth, 5th, 6th, and the 7th position. Now by the time you put 2 raised to power 0, which is the first position, 2 raised to power 1, second position, like that, to 2 raised to power 7, the 7th position. Now by the time you say 2 raised to power 0 is 1, okay, look at the explanation here. 2 raised to power 0 is 1. Okay, and the 1 times 1 is give you 1. 2 raised to power 1 is 2, but you see 0 here. 2 raised to power 1 is 2 times 0. Anything times 0 is 0, so that's how you get your 0 here. Now 2 raised to power 2 here is 4. 4 times 1 will give you 4. Now look here, 2 raised to power 3 is supposed to be 8, but look at here, you have 0. 0 times 8, anything times 0 is 0, so you have a 0 here. Now look at here, then 2 raised to power 4 is 16. 16 times 1 is 16. Then 2 raised to power 5 is 32. 32 times 0 is 0, and so on and so forth. Okay, now this is it here. Now this is an explanation. How do you get 2 raised to power 7? 2 raised to power 7 is the same times 1. Okay, 2 raised to power 7 times 1 here. Just to have an example, just to explain how this is done. So 1 times 2 raised to power 7. 2 raised to power 7 is the same thing as 2 times 2 in 7 places, which is 2 times 2 times 2 times 2 times 2 times 2 times 2. By the time you multiply 2 times 2, you get 4 times 2, you get 8 times 2, 16 times 2, you have 32 times 2, you have 64 times 2, you have what? 128 times 1, you're going to have 128. That is how that is done. I hope you are understanding as we proceed. I hope it's clear to understand. So let's move on. Binary to decimal conversion using the double sequencing method. How do we convert from binary to decimal using the double sequencing method? This is the most interesting part of this class, and it makes binary conversion to decimal very, very simple and easy. Now let's look at this. Look at this double sequencing chart that we have here. Now from 1 times 2, you have 2. If you multiply this 2 times 2, you have 4. If you multiply 4 by 2, you have 8. Multiply 8 by 2, you have 16. Multiply 16 by 2, you have 32. Multiply 32 by 2, you have 64. Multiply 64 by 2, you have 128, and so on and so forth. Okay, this is what we call the double sequencing method of conversion between binary to decimal. So just write on a chart and write the first number, which is 1, multiply it by 2 because you're working on binary numbers. You get 2. Multiply 2 by 2, you get 4. Multiply 4 by 2, you get 8. Multiply 8 by 2, you get 16. Multiply 16 by 2, you have 32. Multiply 32 by 2, you have 64. Multiply 64 by 2, you have 128. If you multiply 128 by 2, you're going to have 256, and so on and so forth. So anytime you want to solve binary numbers and you want it to be extremely fast about it, just simply write this number. Write number 1, then multiply it by 2, you have 2. Multiply 2 by 2, you have 4. Multiply 4 by 2, you have 8, like that. Just write it down. When you write it down, it's going to make your work a lot easier and faster. Okay, let's just show you how it works. Now let's take, for instance, we want to convert this binary number to decimal, to this decimal equivalent. How do we do it? Using the double sequencing method. Now look at this. This is the the binary numbers. Okay, now I'm going to put those numbers with the chart we did before. Let me go back there. Here you see we started from 1, 2, 4, 8, like that, 16 and so on. Now I'm going to put the first number, which is 1, under this first number, starting from the right hand side. So I put 1 under this. The next number is 2, I put it under this. The next number is 4, I put it under this. The next number is 8, I put it under here. The next number is 16, under here. The next number is 32, put it under here. The next number is 64, under this. The next number is what? 128. This is how it is done. Okay, so by the time you do this, now you see that you have 1 here. So you have this. Okay, you write 1. I'm going to explain it further later on. I will going to show you a simple example that we can work with. But look at this. It's similar to what we've done earlier. You know, this is the position. There is 2 raised to the power what? 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6, 2 raised to the power 7, depending on the positions. Now by the time you look at this chart, you will see the similarities between what we are doing right now and what we're going to be doing. Now let's look at a good example. We have this number 1 0 0 1 1 0 1 1. Let's see how we're going to convert it to a decimal number using the double sequencing method. Now the double sequencing method, like we've already done, you see it starts from 1 2 4 8 16 32 64 128. Now let's line up this binary number under this double sequencing chart. Now we'll put this first binary here, the next one like that, and like that we arrange it. Now we look at it one by one. This is the binary number we are trying to convert to decimal. Okay, and this is the number, the double sequencing number that is equivalent to these positions. Now this is the first position. Okay, and it's 1. So you bring down 1 from this double sequencing chart. We'll bring 1 down. Okay, now the next number is 2, plus, we'll put plus. The next number is 2, we'll bring 2 down because it has 1. Now look at this. This is 0. Okay, that means there is nothing here. Here is empty, so we'll bring down what? 0, plus again. Now look at 8. This, it has 1, so we'll bring down 8. 8 is available, plus again. We'll look at this position, 16 position, we have 1 there, so we'll bring it also down because it's also what? Available. So we're going to make use of 8 because it's also what? Available. So by the time we get there, we'll see that this is a lot easier. Let me quickly run through. Sorry for this interruption. Okay, now look at this. By the time we get here, 16, by the time we get here, we bring this down, 16. Okay, at 32 position, there is nothing there, we'll bring down 0. 64 position, nothing there, we'll bring down 0. At the position of 128, there is 1, so we'll bring down 128. By the time you add these numbers together, you're going to have 155, and that is the binary, the decimal equivalent of this binary number. Isn't this simple? In our next class, we're going to proceed from here. We're going to explain further and then do addition, subtraction, multiplication, and division of binary numbers using the double sequencing method. Thank you, and I hope you enjoyed the class. See you in the next one. God bless. And don't forget to subscribe to our channel, because this will help us pass these trainings to other people and other students. We will appreciate you subscribing. Please subscribe to our channel.